Hello everyone, my name is Timothy Joseph. In this video, I'm going to teach you circle geometry. I've prepared 4 examples in which I'm going to use to help you to learn circle geometry. And by the time you finish watching this video, you should be able to find any missing angle in a given problem. But before we begin the lesson, I need you to take a look at this diagram. This diagram is an angle A, which is a circumscribed angle on circle O. What is the measure of angle A? Yeah, so look at this angle. What is the measure of this angle? So find the value of this angle and write your answer in the comment box. But if you cannot find it now, don't worry. Just take your time to watch this video to the end. You are going to learn how to figure it out by yourself without stress. So let's begin. Our first example, PQRS is a cyclic quadrilateral with theta at the center of the circle. What is the value of the angle theta? So in this problem, we need to first find SPQ, that is this angle here. And then by the time we get the value of this SPQ, we can now find this theta, which is at the center, easily. So we are going to say that SPQ is equal to 180 degree minus 140 degree. Why is it so? The Circle Theorem says that opposite angles of a cyclic quadrilateral are supplementary. When we had two angles together and they equal to 180 degree, we call such angles supplementary angles. But according to the Circle Theorem, angles of a cyclic quadrilateral are supplementary. That is, the opposite angle of a cyclic quadrilateral are supplementary. This angle R or SRQ is opposite SPQ, is opposite to this, and this is also opposite to this. So we call these two angles supplementary angles. So we say SPQ equal to 180 degree minus 140 degree, which is 40 degree. So once again, let me remind you, opposite angles of a cyclic quadrilateral are supplementary. Let me just write it at this corner for you to remember. So we have found SPQ. Now we can now find S theta Q, that is this angle at the center here. So we will say that S, since SPQ is 40 degree, then S theta Q is equal to 2 times 40 degree. Why again? The reason behind this is that angle subtended at the center by an arc of a circle is twice the one subtended at any part on the circumference. This is according to Circle Theorem. So if you don't understand Circle Theorem, it will be difficult for you to tackle any problem in circle geometry. So I would advise you to study the theorem by yourself. Once you understand the theorem, it will be easier for you. But I'm going to mention some of the theorems in this problem. Please take note of those theorems. They are going to be helpful to you. So I'm going to write this down for you again for you to So this is a theory or theorem. angle subtended at the center by an arc of a circle is twice the one subtended at any part on the circumference. So we can now say that our angle S, this angle at the center is 80 degree, of course. So let me just write it here. So angle S theta Q is equal to 80 degree. So we find SPQ, this angle first, and then after getting that, we can now find S theta Q using the circle theorems. So let's consider another example. Two. So let's get rid of this. This is another example. If point O is the center of the circumference in the diagram below, calculate x. Calculate x. So in this problem, we have to find x. Take a look at this. ROQ, triangle ROQ is an isosceles triangle. Yes, and then you also need to remember that the base angles of an isosceles triangle are equal to each other. Okay, so let's work it out. So in this problem, for us to find angle x or RQO, this angle x, we must find this ROQ. And after getting this value, we can find angle x easily. So we will say that angle ROQ is equal to 2 times RP, this Q. We have angle P, RPQ. Why? See the same reason. So the angle subtended at the center by an arc of a circle is twice the angle subtended at any part on the circumference. So this angle here is twice of the angle that is here. No, sorry. The angle at the center is twice of the angle that is here. So we just say 2 times this. So let me write the reason here. So angle subtended at the center by an arc of a circle is twice the one subtended at any part on the circumference. So this angle is half of what is here. Why this one? Angle at the center is twice of the one that is at any part on the circumference. So that here, here, or here. And then we've got an angle here. So we're going to make use of this value here. So we just say that ROQ is equal to 2 times 50 degree. And then we have our ROQ is 100 degree. So, okay. So we have found this angle. Then we need to find angle X now. And I said that this ROQ, this triangle ROQ, if you can look at it very well, it is an isosceles triangle. So, and then the base angles of an isosceles triangle are equal. So you are going to say that ORQ of course is equal to RQO, which is given as x, so equal to x degree, because these angles of an isosceles triangle are equal, so which is ROQ. So okay, so we say ORQ plus RQO and RQO plus angle ROQ is equal to 180 degrees. Why? The sum of angles in a given triangle is 180 degrees, and we have gotten triangle ROQ here. So, which is an isosceles triangle. So, let's put the angle sign. Okay. So, ORQ is equal to RQO, which is given as x. So, we say this is x plus x plus ROQ, which we have found to be 100 degrees. Okay, equal to 180 degrees. So here we have 2x plus 180. No, so let's just collect the like terms. Equal to 180 minus 100. So we have 2x equal to 80 degrees. Okay, and then dividing both sides by 2, so we're going to have x equal to 80 degrees minus, sorry, divided by 2. What's wrong with me? So divided by 2, so we have 40 degrees. So the value of our angle x is 40 degrees. So this is very simple to calculate. So once you understand the theorems, the calculation will be very easy for you to do. So let me take time again to explain. We have to find the value of this x in this diagram, and then we have triangle angle ROQ. This triangle ROQ, we say that is equal to 2 multiplied by RPQ. Why? Because angle subtended at the center by an arc of a circle is twice the one subtended at any part on the circumference. So we need to find this angle first, and then for us to find this angle, we must apply this theorem, and then which means we are going to say 2 times 50, which will give us 100 here. So here we've got 100, and that's where we got 100 degrees here, that is angle ROQ. And then since we have one of the angles in this triangle, which is an isosceles triangle, knowing fully that the base angle of an isosceles triangle, the base angles are equal, so we just applied the rule again to get the value of this x, and that is what we did here. So our ORQ is equal to RQ, which is given as x degree. So this angle plus this angle equal to 180 degrees. So that's what we did. And then we label this side as x as well. And x plus 100 degrees equal to 180 degrees, sum of angles in a given triangle. And then we have 2x equal to 180 degrees minus 100 when we collect like terms. So 2x equal to 80 degrees because 180 minus 100 is 80 degrees. So dividing both sides by 2, we have x outside, which is equal to 80 degree divided by 2, and then we've got 40 degree. So this is very simple. So let's take a look at another example. Example number 3. So let's get rid of this. So this is another example. In the diagram, A, B, and C are points on the circle center O, radius 14 centimeter. In the diagram, A, B, and C are points on the circle center O, which radius is given as 14 centimeter. So angle ACB is given as 42 degree. Find the acute angle AOB, and then the second problem, the length of the major arc ACB. The length of the major arc ACB. So this is another problem for us again to tackle. So we're still going to apply the theory to find this. So we need to find the acute angle AOB. So I think something is missing. There should be C here. Yeah, C is here. So let's write it. C. So here is C. Okay. It's balanced now. So in this problem, we need to find this angle again. Angle AOB. The acute angle AOB, we need to find it. Angle AOB, this acute angle is an angle that is less than 90 degree. So we're going to find it. So by the time we get the value of this angle, it must be 90 degree. If it is more than 90 degree, it means our solution is wrong. So we say that the acute angle AOB is equal to 2 multiplied by ACB. ACB. Why? Because angles subtend at the center of a circle by 2 arc is twice that which it suspends at any point on the remaining part of the circumference. So that is the reason. So I'm still going to put it here again for no, not this. So angle AOB is equal to 2 times angle ACB because of this reason. So angle AOB is 2 times 42 degree. Therefore, say that AOB is 42 degree. Okay, so that is, what am I saying? Did I say 42 degree? Goodness, what's wrong with me? So this should be 84 degree, not 42. So let me just get rid of this. So 84 degree. 64 degree. So this is the arcuate angle AOB. You can see it is less than 90 degrees. So let's go ahead and find the second one. Okay, second problem. So the second problem says the length of the major arc ACB. So length of this major arc ACB. So length of arc ACB. So to calculate this length of arc ACB, we are just going to apply this formula. Length of an arc which is given as L equal to theta divided by 360 degree multiplied by 2 pi r. Yeah, 2 pi r. Okay, so we substitute now. Our L is, what's our theta at the center? What do we have? What angle do we have at the center? Yep. Yeah. So the angle at the center here, this angle here. So this is like a reflex angle or angle at the point. So we are going to say 360 minus 84 to give us this theta. And then it's going to be, we should have 274 divided by 360. Yeah. Then multiply by the value of 2 times pi, each pi, then times the radius of the cycle. What is the radius again? Do we have 14? Yeah, of course 14. Okay. So this take out this. We have 2 left. So we draw down again. So when we multiply everything here, we should have our length of the arc. We should have 24,288 divided by 360. So what do we have? Let's punch calculator and see. Okay, so we have 67.47 centimeters. So this is the length of the major arc ACB. It's the length. So let me quickly re-explain what I've done here again. So for you to find the arcuate angle AOB, you apply this theorem. So angle AOB is equal to 2 times ACB because it is an angle at the center that we're looking for, AOB, which is twice the one subtended at any part on the circumference, and then basically we're multiplying this angle ACB by 2, so that is 2 times 42 degree, and then we got the value as 84 degree here, and then we come down to the B part, which says we should find the length of the major arc ACB. Length of the major arc ACB is given as this length of an arc, and then we need to find this theta, that is the angle here, and then the angle here can be found by saying 360 minus 84 degree. Yes, 360 minus 84 degree because it is an angle at the point or a reflex angle. So we will get 276. Oh, 274. So this must be 276, not 274. 276. Yeah. So when we say 360 minus 84, 276, then we can just go ahead and do the calculation, and then we get this value, which is 67.47 centimeter, like this. Okay, so let's move to the next example. Let's get rid of the screen. So this is the last example. Calculate the value of angle x in the above diagram. Calculate the value of angle x in the above diagram. So this is very simple based on the theorems that we have considered. Yes, that is angle subtended at the center of the circle by 2 half is twice of that which is subtended at any point on the circumference. So to find angle x, we need to find this angle PORQ. Sorry, POR. We need to find POR before we can find angle PQR. So we say that PO is equal to what? 363 minus 114. Why is this? Angle at the points. Let's go to 360. Angle at the points. So that's the reason. So what do we have? 360 minus 144. Okay, so our POR equal to so this angle POR is 246 degrees. So also we can say that this reflects angle POR, therefore angle POR is equal to 2 times the angle at the center. 2 times angle at center is twice angle at circumference. So we are looking for this this angle. So we're going to say POR is equal to 2x, and I'm multiplying this time. So POR equal to 2x for us to find to get this angle. Why are we saying that? So angle center is twice angle at circumference. So POR equal to 2x, which means we are dividing this value by 2x to get this value. Yeah, so the half of the angle at the center is going to give us the angle at the circumference here. So according to circle theorem, so we have x equal to 246 divided by 2. So what do we have? We should have 1, 2, 3. It's 123 degrees. So we got this angle here based on the circle theorem. So angle at the circumference is twice the angle. So this is where we're going to stop in this circle geometry lesson. I'm sure by now you'll be able to find any missing angle in a given problem. Thank you for taking your time to watch this video. Please do like this video, subscribe to my page, follow me, and make comments. Thank you.